So hi guys, this is your favorite math teacher, DPA Math Tutorial. And today I'm here to take you through the topic rational function in elective maths. So far as the West Africa Examination Council is concerned. So somebody may ask what is a rational function or what is a rational function. So rational function is simply the form of rational function is the function in the form of rational function is the function in the form of P of x over Q of x. So rational function is a function in the form of P of x over Q of x, where P of x and Q of x are all polynomial functions. Polynomial functions. So we said rational function is in a function in the form P of x over Q of x, where P of x and Q of x are all polynomial functions. Then somebody will also ask what's a polynomial function. So you can go through my videos and you see the last time we treated the polynomial function for more understanding. Now, in polynomial function or the rational function in the form of P of x and over Q of x, where both P and Q are all polynomial functions, you take the case where the denominator, we are going to take the degree. So the degree. So when we talk about the degree, in other terms we say powers. Are you okay? So whenever the degree of the numerator, is greater than the degree of the denominator, it's called improper fraction. Whenever the degree of the numerator is greater than the degree of the denominator, then it's called what? Improper fraction. In vice versa, is that whenever the degree of the denominator is greater than the degree of the numerator, then it's called what? Proper fraction. Somebody may, it may sound very weird to your ears, but let me break it down mathematically. So mathematically, we can say that when we have x plus 1 over, let's say, x squared plus 2. Let's say this is an example. So we have example like this. And let's say when we talk about the degree, we talk about the powers of the variable of what? Interest. So what are the variables here? It's x. So what's the power here? We have this to the power what? 1. And this one is the power what? 2. So these are called degrees. Mathematically they are called what? Degrees. So when you say whenever the degree, so we know that this one, what is up here is called the numerator. This one is called numerator. And then the down one is called what? The denominator. It's called the denominator. Now whenever we say, so from our definition, we said whenever the degree, so here was to the power of 2. Whenever the degree of the numerator is greater than the degree of the denominator, then it's called improper fraction. So for example, when you have x to the power 3 plus 2x plus 1 all over 2x plus, let's say, x plus, let's say, 4. Now let's check the degree. We have the variable here which is x, we have a variable here which also called x. But let's check the one with the highest what? Degree. As you can check, the denominator is having x with the highest what? Degree or highest power. Whilst this 3 here is greater than this. We said because the degree of the numerator here is greater than the degree of the denominator here, we said it's what? Improper what? Fraction. So what? Improper fraction. Vice versa, whenever the degree of the denominator is greater than what the degree of the numerator is called what? Proper fraction. So this one can be termed as what? Proper fraction. It's called proper fraction. Now, once we have come to know what a rational function is, then we move on to the subtopic under rational function. So we look at the domains of rational function. So domain of a rational function. So what is the domain of a rational function? What is the domain of a rational function? Once we have understood the definition or what is meant by what a rational function, then somebody also may ask, what is the domain of a rational function? So when we talk about the domain of a rational function, it's a set of all possible values of a real numbers. It's a set of what? All possible values of what? Real numbers, except the zeros of the denominator. So it's a rational function is always in the form p of x over q of x. And we are saying the domain of a rational function is the set of all possible real numbers except the zeros of the what? The denominator, except the domains of the what? Zeros of the what? The denominator. Except the what? The zeros of the what? Denominator. So we talk about the domain of a rational function, the set of all possible what? Real numbers, except the zeros of what? The denominator. That's q of what? X. So let's take an example. So for example 1. So let's see example 1. Find the domain of 1 over x plus 2. Instead we should find the domain of x plus 2. So if you have to find the domain of the function x plus 2, so if you cancel, then place the function 1 over x plus 2. So based on our definition, we said the domain of a rational function is a set of what? All possible real numbers except the zeros of what? The denominator. So all that you need to do is that you take the denominator, you put to what? 0. You take the denominator, then you put to what? 0. So what is the denominator? This is what we have here. So this is x plus 2, then you put it to 0. Therefore, x is equal to what? Negative 2. X is equal to what? Negative 2. X is equal to negative 2. Therefore, what is the meaning of negative? Meaning that whenever you put negative 2 here becomes what? 0. So for instance, after solving, try to put the x back. So you are going to have negative 2 plus 2. Giving us 1 over 0. So in this mathematical, we say undefined, or it does not what? Exist. I okay. Whenever you have a number divided by 0, it has no meaning. Are you okay? So we say it does not what? Exist. So from there you write the domain. So the domain equals to, you say we write x side that x belongs to all real numbers. All real numbers. All real numbers except, this means what? Except negative what? 2. You can write the except in words. Except s equal to negative 2, or if you put this one, it means what? Except. So we have 2 ways. Either you write it in what? Words here, or you put equal to and then you cross it. Then let's take example 2. Example 2. Example 2. So example 2. Find the domain of the function bracket s plus 2 s minus 3. So they say we should find the domain of the function 2 on s plus 2 s minus 3. So all that we need to do is what? To equate the denominator to equal to what? 0. So we take the denominator and equate to 0. So we are going to have s plus 2 x minus 3 equate to 0. Therefore, if you equate this one to 0, we are going to have s equal to negative 2. Then if you equate only this one to 0, we are going to have s to what? Positive 3. So therefore, then we come and write the domain. So the domain equal to s is that s belongs to all numbers. Except when s is not what equal to negative 2 or 3. And I hope now you can solve more questions on the domain. So let me give you one quick one, so you try it on your own at your own convenient time. You try to simplify. So let's take that one to example 3. And that one you can solve it at your own convenient time, at your own pace. You can solve it. So let's take that one to example 3. So example 3. Find the domain of this one. So this solve question, now you can solve it, but I'm solving it. Once you are done, you can recheck your answer if it is correct. So we just take the denominator equate to 0. So we are going to have x minus 1 and equate to 0. And this one can be rewritten as s squared minus 1 squared, because if you store 1, it still gives you what? 1. So what now we have this is called difference of what? 2 squares. Difference of what? 2 squares. We are going to have s squared. So plus 1 s squared. S plus 1, s minus 1 equate to 0. Now we take this one and we equate it to 0. We take this one to equate to 0. Therefore, we are going to have x to be equal to negative 1. And if you equate this one to 0, we are going to have x to what? Positive 1. So x equal to negative 1 or positive 1. Then you write your domain. Therefore, domain is equal to s is to s, such that s belongs to all real numbers except when s is equal to negative 1 or 1. Now, I hope we've now understood what the domain, because we have solved several examples So you can go through all over and over, and I think you understand it very well. Now let's look at another subtopic as the rational function, which is called range. Range. So let's take example. So let's take a range. So what is a range? So let's start topic, which is range and the rational function. So what is range? What is range? Somebody may ask, what is range? And if you hear range, or if you have been asked to solve for range, how would you go about it? So simply, range is all values of y. It talks about all values of y which will make x defined. It talks about all values of what y which will make what x what defined. So it talks about all values of y which will make x defined. So with this definition, let me solve one example and I will use to explain it to you for further understanding. So let's take example 1 quick without wasting much time. So example 1. We have find the range of 1 over x plus 2. When you want find the range of y equal to 1 over x plus 2. Or let's see the function, let me use this of the function f of x. Are you okay? So let's find the range of the function f of x equal to 1 over x plus 2. So let's solve it. So in solving it, we know that in the function f of x can also be represented by what? Y. The function f of x also can be represented by what? Y. So we said let y equals the function given. Let y equals the function. That's 1 over x plus 2. Now, main aim, based on definition, we said it's a set of all possible values of y which will make what? X defined, meaning all that they are simply saying that make x the what? Subject. I will make what? X the subject. So from here, our aim is to make x the subject. So what should we do? This one is over 1, this one. So we multiply, we do cross multiplication, or we multiply it through by what? Common LCM. So if you have to do cross multiplication, this one will come and multiply this. You are going to have y multiplied by x plus 2. Then this 1 times 1 will give us 1. Let us expand the bracket. I'm going to have x y plus 2y equals to what? 1. Therefore, our main aim is to make x the what? Subject. So from here we duplicate x by sending all those with x to one side and those without x to one side. So we have x here. So we maintain this one x y. Then the one and we send the 2s. Yeah, so whenever the 2s is what you brought the equal sign, it comes out negative. Therefore, we want x, not x squared. So we divide both sides by the coefficients of what? X and we are going to have x, y, then we divide this by what? 1 equal to 1 minus 2, 1, which is equal to what? Y. So this y cancels, therefore x equals to 1 minus 2y over what? Y. And they said the range is the all set of possible values of y, which will make x what? Defined, which will make us get a value for what? X. Are you okay? So any number which will not make us get a value for what? X is out of range. Are you okay? So we are finding those who are within the range. Are you okay? That's why I say range. So let's take, for instance, because this one, if you equate this one, the denominator to 0, meaning y is equal to 0. So if you put 1 minus 2 times 0 all over 0, automatically you are going to have 1 over 0, which is undefined. But any other value that you put here will make the what? The function was defined. For instance, let's put For instance, let's put any other value aside 0. So let's put 1 there. So we are going to have 1 minus 2. So we put 1 wherever you see 1. All over y, which is 1. So this one will give us 1 minus 2 over 1. So which we are going to have negative 1 over 1, which is equal to negative 1. So let's take one more example. We solve the second example. So let's solve one example and array. So let's take example 2. So example 2. Find the range of the function f of x equals 3x over x minus 1. So the first thing you need to do, as we did earlier, first you said let y equals the whole function, which is 3x over x minus 1. From here, because our main aim is to make x the subject, it is either you multiply through by the LCM or you do cross multiplication. Any way that you use or any form will still give you the same answer. So if you are to do cross multiplication, you are going to have y multiplied by x minus 1 equal to 1 times this 1 times what? 3x. So let's expand the brackets. So if you have to expand the brackets, we are going to have y times x, which will give us yx. Y times minus 1 will give us minus 1 equals 1 times 3x, which will give us what? 3x. So from here, our main aim is to make x the subject. So from here, it's called for what? Something called groupization. So you group everything. Or IOP, you group everything. So by grouping is our main aim is to make x the subject. So you group those with x to one side and those without x, or different variable as well to one side. So let's bring this one here and send the one with that s to the other side of the equal to sign. So you are going to have y s, then you have this one first, it becomes negative minus 3x equals to y. So I think s is common to this side, so you can factorize s out. So if you factorize s out, you are going to have y minus 3 equals to y. Therefore, we want s, not s multiplied by what's in the bracket. So we divide both sides by the coefficients of the what? X. We are going to have s multiplied by y minus 3 divided by y minus 3. We do the same thing to the other side. This is y minus 3. So this one cancels it. Therefore, our x is equal to y over y minus 3. So once you are plotting this, this becomes the range. So the range write the range is therefore equal to this. Now let's always equate the downward to 0. So we are plotting the answer to be y over y minus 3. If you equate this one to 0, we are going to have y minus 3 equal to 0. Therefore, y is equal to what? 3. But y cannot be equal to 3 because if you use y to be equal to 3, to make the whole thing to what? Undefined. Because if I put y back, if y cannot be equal to 3, y cannot be equal to 3 because if I put this 3 here back, it's going to make the whole thing to be undefined. So I'm going to have 3 over 3 minus what? 3. It's going to be 3 over what? 0. This is going to give us what? Undefined. So this is where we end our lesson for today. And the next time we meet, you continue. And if you have not subscribed to my channel, please kindly subscribe to Daniel. So the name is subscribe to DK Maths Tutorial for more content. Thank you.